Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. Before developing a regulated power supply, by placing Lm7812, Lm7912 and Lm7805, we'll check if there is any short circuit in our bridge rectifier circuit. First, we will perform a dry test using a multimeter. First, we will perform a short circuit test in our bridge rectifier for positive and negative side of our bridge rectifier. Okay, there is no short circuit. Now we'll check if there is any short circuit in our AC input connection. Here we have 0 volt and here we have 12 volt AC. Okay, there is no short circuit. Now we'll test 0 and another 12 volt input. Okay, there is no short circuit in it. Now we'll connect the transformer, that is 12 volt, with our bridge rectifier, and we'll check the positive and negative side of our bridge rectifier. For this, we will energize our transformer by applying 220 volt at input, and we'll check the output of our transformer. First, I'll connect 12 volt AC at one end. I'll connect 0 volt winding in the middle. And the next AC input on the other side. Now I'll energize the transformer by applying 220 volt. By selecting a proper voltage input range for our multimeter, we'll check the primary input voltages for our transformer. Now I'll apply 220 volts at the primary of the transformer. Here we can see that 228 volts are coming at the primary of our transformer. Now we'll check the output voltages of our transformer. Now we'll select the proper input range for our multimeter, because we will measure 12 volt at the output of our transformer. Here we have output of our transformer. I'll place one probe of my multimeter at the center point of this connector, and I'll measure the voltages on other end. Here we can see 13.55 voltages are coming at one end. Now I'll check the second end. Here we can find 13.55 voltages are coming on the other winding also. Now I'll connect the transformer to the input of our bridge rectifier, and we'll check unregulated DC voltages. Now I'll apply AC input voltages at the input of our bridge rectifier. Now I will energize the transformer once again, and I'll check the AC input voltages. Here we can find 13.55 voltages are coming. Now I'll check other end. Okay, AC voltages are coming. Now we will check the DC voltages. By placing the negative end of the multimeter at the center point, I'll check the positive and negative ends of the bridge rectifier. Now I'll select the range for DC measurement. Okay, I'll check positive end. Here we can see 18.37 volts are here at the positive end of the bridge rectifier. Now I'll check the negative end of the bridge rectifier. Here we can see minus 18.36 volts are coming at the negative end of the bridge rectifier. It means that the voltages at the capacitors are 18.35 volts. Here we can check once again. Here we have the positive end of the capacitor, and here we have negative end of the capacitor, and negative of the first capacitor is connected to the positive end, which is 0 volt. That is the 0 volt winding of the transformer. Now we'll use the voltage regulators, that is Lm7812, Lm7912 and Lm7805. Here we have 3 voltage regulators, that is Lm7812, Lm7912 and Lm7805. All 3 regulators are TO220 package. Before connecting these voltage regulators in our circuit, we will place these regulators on heat sinks for proper heat radiation. Here we have heat sinks for TO220 package. Now we will mount all 3 regulators on heat sinks. Here we have screws and nuts to fix these regulators on heat sink. We are using 3 heat sinks for all 3 regulators, so there is no need of placing any isolation kit for these regulators. But if we would like to place all 3 regulators on a single heat sink, then we will use a proper insulation kit to make them isolate from each other. But at this stage there is no need of using the isolation kit because we are using 3 separate heat sinks for 3 regulators. Before placing these regulators on heat sink, we will use a heat sink compound to transfer proper heat from device to the heat sink. Here we have heat sink compound. Now we have placed the regulator on heatsink properly. Similarly, we will place other 2 regulators on the heatsinks also. Now all 3 regulators are placed on their heatsinks, and now we will use them in our circuit to make regulated power supplies, that is plus 12 volt, minus 12 volt and plus 5 volt. First we will place Lm7812 in our circuit. Here we have Lm7812, and the left pin is pin number 1, pin number 2, then pin number 3. The left pin, that is pin number 1, is unregulated DC input. The middle pin is ground, and the rightmost pin, that is pin number 3, is regulated 12 volt output. Now we'll place this regulator in our circuit accordingly. Here we have unregulated DC input, and we have ground at this point, and this side is the positive side of our power supply. So we'll place Lm7812 at this side. Here we have placed 7812 in our circuit. Now we'll solder this regulator in our Vero board. I'll solder one pin. Now I'll observe the position of the regulator. It is inserted properly in the circuit. Now I'll solder rest of the pins. Now I'll apply unregulated DC input to the pin number 1 of this regulator. Now we can check the regulator is properly soldered in the circuit. Here we have unregulated DC input, the second pin is ground, and the third pin is regulated 12 volt output. Now we'll check the continuity of our circuit and we'll check the output voltages. For this we'll use the multimeter. Here we can check the input is connected to the unregulated DC input. Now we'll check the ground connection. Okay, the ground is connected properly. Now we'll check the short circuits for input and output. There is no short circuit between ground and input. Now we'll check the output short circuit. There is no short circuit between the ground and the output of the regulator. Now we'll again energize our circuit and we'll check the output of our regulator. We'll set the voltage range of multimeter to 20 volt DC. Now we'll connect the AC input voltages and we will power up the transformer. We'll check the voltages with respect to the center pin of the connector. Here we have unregulated voltages. We can find 17.76 volts. Now we'll check the output of the regulator. Here we can see 11.9 volts are there. It means that voltage regulator is regulating the voltages properly. Now we'll complete our circuit accordingly. Here we have Lm7912 regulator. It is again a 3-pin device. The leftmost pin is pin number 1, the middle pin is pin number 2, and the right pin is pin number 3. There is a difference between pin configuration of Lm7812 and Lm7912. Pin number 1 of Lm7912 is ground, pin number 2 of Lm7912 is input, and pin number 3 is output. But for Lm7812, the pin number 1 is input, pin number 2 is ground, and pin number 3 is output. We will place this regulator in the circuit as per pin configuration. We'll connect the pin number 1 to the ground and we'll apply unregulated DC at pin number 2 and we'll take regulated negative voltages from pin number 3. Now we have placed Lm7912 regulator in our circuit. First we will solder only one pin. And we'll check if the regulator is connected properly in the circuit. Here we can see the voltage regulator is properly inserted in the Vero board. Now we'll solder other 2 pins of this regulator. As we know, the pin number 1 is ground, so we'll connect the pin number 1 to the ground. Now we'll check the short circuit between input and output of this regulator. Okay, there is no short circuit between input and the ground. Now we'll check the output and the ground. Okay, there is no short circuit between output and the ground. Now we'll check the output voltages for this negative voltage regulator. For this I'll connect AC input. And I'll select the range of multimeter to the DC input. I'll place the negative end in the middle of this connector. I'll check the center pin. Here we have 17.53 unregulated DC input. Now we'll check the output. Here we have minus 12.12 volt at the output of this regulator. It means that we have developed plus 12 volt and minus 12 volt power supply. Now we'll connect frequency compensation capacitors with these regulators. Here we can see C1, C2, C6, C7 and C3. These capacitors are frequency compensation capacitors for these regulators.